Imagine holding in your hands a metal so light it feels almost unreal, yet so strong it helps power spacecraft through the cosmos, protects astronauts from deadly radiation, and enables the smartphones in our pockets to connect us instantly across the globe. What if I told you this remarkable element is also one of the most toxic substances you could encounter, capable of devastating human lungs with just a few particles? This paradox exists in a single element on the periodic table, an element that most people have never heard of, but that quietly revolutionizes technology all around us. Today, we're diving deep into the fascinating world of beryllium, element number 4, and trust me, by the end of this journey, you'll never look at modern technology the same way again. Before we go any further, let me ask you something. Have you ever wondered what allows satellites to survive the brutal conditions of space, where temperatures swing from scorching hot to freezing cold in minutes? Or how scientists manage to peer into the structure of atoms themselves? Drop a comment below with your guess, because the answer involves our mysterious friend beryllium, and the story is far more intriguing than you might imagine. And hey, if you're already hooked on uncovering the secrets of elements that shape our world, smash that like button and subscribe, because we're about to explore one of chemistry's most fascinating characters. Let's start with the basics, but don't worry, this won't be a boring chemistry lecture. Beryllium is a silvery, white metal that sits right near the beginning of the periodic table, nestled between lithium and boron. It was discovered back in 1798 by a French chemist named Louis-Nicolas Vauquelin, who found it hiding in emeralds and a mineral called beryl. In fact, that's where the name comes from, beryl, the beautiful gemstone. But here's the thing that makes beryllium absolutely extraordinary. It's incredibly light, weighing less than half as much as aluminum. Yet when you combine it with other metals, it creates alloys that are stronger than steel. Think about that for a moment. A metal lighter than aluminum, but stronger than steel. It's almost like nature created the perfect engineering material, and then hid it in plain sight for centuries. But the story of beryllium isn't just about its physical properties. It's about how this element sat largely unused and underappreciated for over a century after its discovery. During the 19th century, scientists knew beryllium existed. They could identify it and extract it from minerals, but they couldn't figure out what to do with it. It was expensive to produce, difficult to work with, and its unique properties weren't yet needed by the technology of the time. Beryllium was like a solution waiting for a problem to solve. And then came the 20th century, and suddenly, humanity started reaching for the stars, splitting atoms, and building machines that required materials with properties that simply didn't exist in conventional metals. Now, let me paint you a picture of where beryllium becomes absolutely essential, and this is where things get really exciting. Picture the James Webb Space Telescope, that magnificent piece of technology that's currently sending us images of galaxies billions of light years away, showing us the universe as it existed shortly after the Big Bang. The mirrors on that telescope, those precisely engineered surfaces that need to maintain their exact shape in the freezing vacuum of space, are made of beryllium. Why? Because beryllium has this remarkable property where it barely expands or contracts when temperatures change. In space, where one side of a satellite might be baking in sunlight at hundreds of degrees, while the other side faces the cold void at near absolute zero, most materials would warp and twist, rendering precise instruments useless. Beryllium just sits there, stable and unchanging, allowing those mirrors to maintain the nanometer precision needed to capture light from the dawn of time itself. But space applications are just the beginning. Come back down to Earth with me for a moment, and let's talk about something you probably interact with every single day: your smartphone. Inside that sleek device in your pocket, there are tiny beryllium copper springs and connectors. These aren't just any springs. They're components that need to flex millions of times without breaking, conduct electricity efficiently, and resist corrosion from the sweat on your fingers and the humidity in the air. Beryllium copper, an alloy containing just 1 to 3% beryllium mixed with copper, is 6 times stronger than regular copper, while maintaining excellent electrical conductivity. Every time you press a button, plug in a charger, or your phone connects to a cell tower, there's a good chance beryllium is involved in making that connection happen reliably. And here's where I want you to engage with this. Think about all the technology you use daily: your laptop, your car, medical equipment you might encounter, the infrastructure that powers your city. How many of these do you think might contain beryllium? Drop your thoughts in the comments below, because I bet you'll be surprised by just how ubiquitous this element has become in our modern world. And if you're finding this exploration fascinating, show some love with a like. It really helps us continue bringing you these deep dives into the science that shapes our reality. Let's venture into one of the most critical and dramatic applications of beryllium nuclear technology. This is where things get intense, both scientifically and historically. When scientists were racing to develop nuclear weapons during World War II and the Manhattan Project, they discovered that beryllium had a unique property that made it invaluable. When you bombard beryllium with alpha particles, a type of radiation, it releases neutrons. Now, neutrons are absolutely crucial for nuclear reactions. They're the particles that smash into uranium or plutonium atoms, splitting them apart and releasing enormous amounts of energy. Beryllium became essential as a neutron reflector in nuclear weapons, surrounding the radioactive core and bouncing neutrons back into it, making the chain reaction more efficient. It's a bit sobering to realize that this lightweight metal, which seems so innocent, played a crucial role in one of humanity's most powerful and destructive technologies. But let's balance that heavy historical note with beryllium's role in peaceful nuclear applications. In nuclear reactors that generate electricity, beryllium is used as a moderator, controlling the speed of neutrons to keep reactions stable and productive rather than explosive. It's also used in neutron sources for scientific research, allowing physicists to probe the structure of materials at the atomic level. There are facilities around the world where beryllium targets are bombarded with particles to produce neutron beams, and these beams are then used to study everything from new medicines to advanced materials for future technologies. So while beryllium has this dark side in weapons development, it's also instrumental in advancing human knowledge and generating clean energy. Now I need to tell you about the elephant in the room, or perhaps I should say the toxic element in the room, because here's where beryllium reveals its dangerous side. Remember how I mentioned at the beginning that beryllium is one of the most toxic substances you could encounter? This isn't an exaggeration. When beryllium is machined, ground, or processed, it creates dust and fine particles, and if those particles are inhaled, they can cause a devastating disease called chronic beryllium disease, or CBD. This condition causes the immune system to attack the lungs, leading to inflammation, scarring, and in severe cases, respiratory failure. Workers in industries that process beryllium have to follow incredibly strict safety protocols, wearing protective equipment and working in carefully controlled environments. The disease can develop years or even decades after exposure, making it particularly insidious. Here's what makes this even more interesting from a scientific standpoint. Not everyone exposed to beryllium develops the disease. Scientists have discovered that there's a genetic component. Certain people have immune systems that react to beryllium, while others can be exposed without developing the condition. This has led to genetic testing in industries that work with beryllium, helping identify workers who might be at higher risk. It's a fascinating intersection of chemistry, biology, and occupational health, showing how our individual genetic makeup can determine our susceptibility to environmental hazards. This toxic nature of beryllium is precisely why it's not used in consumer products where people might directly handle it or breathe dust from it. Its applications are restricted to controlled industrial and technological settings where proper safety measures can be enforced. Let me take you into the world of acoustics for a moment, because beryllium shows up in a place you might not expect: high-end audio equipment. Audiophiles, those passionate enthusiasts who spend thousands or even tens of thousands of dollars on speaker systems, prize beryllium for its acoustic properties. Speaker domes made from beryllium can reproduce sound with exceptional clarity and accuracy, because beryllium has extraordinary stiffness and low weight. When a speaker cone needs to vibrate rapidly to reproduce high-frequency sounds, the material needs to be stiff enough to move as a single unit without flexing or distorting, yet light enough to respond instantly to the electrical signal driving it. Beryllium hits that sweet spot better than almost any other material. The result is speakers that can reproduce the shimmer of a cymbal or the breathy quality of a vocalist with stunning realism. Of course, these speakers are expensive and their manufacturing requires careful handling of beryllium, but for those who demand the absolute best in sound reproduction, beryllium tweeters are often considered the gold standard. Now let's talk about something that affects millions of people's lives directly: medical imaging technology. In X-ray machines, there are thin windows that allow X-rays to pass from the tube where they are generated out toward the patient. These windows need to be strong enough to maintain a vacuum seal, because X-ray tubes operate in vacuum, yet thin and transparent enough to let X-rays pass through without significant absorption. Beryllium is ideal for this application. Its low atomic number means it's relatively transparent to X-rays, allowing them to pass through efficiently, while its strength allows for thin windows that don't absorb or scatter the radiation unnecessarily. Every time someone gets a dental X-ray, a chest X-ray, or any number of medical imaging procedures, there's beryllium quietly facilitating the process, helping doctors see inside the human body without surgery. Here's something I find absolutely mind-blowing, and I want you to really think about this. Beryllium is used in particle accelerators, those massive scientific instruments where physicists smash particles together at nearly the speed of light to understand the fundamental nature of reality. At facilities like CERN in Switzerland, home of the Large Hadron Collider where the Higgs boson was discovered, beryllium is used in the beam pipes and other components that must be strong, yet allow particles to pass through with minimal interference. When scientists are trying to answer questions like what happened in the first moments after the Big Bang, or what is the nature of dark matter, or why does matter have mass, beryllium is there as an enabling technology. Think about that. An element discovered in gemstones over 2 centuries ago is now helping humanity probe the deepest mysteries of existence itself. Tell me in the comments, does that blow your mind as much as it does mine? And if you're loving this journey through the applications of beryllium, don't forget to hit that subscribe button so you never miss our explorations of science and technology. Let me tell you about beryllium's role in the aerospace industry beyond just spacecraft mirrors. When engineers design aircraft, especially military jets and helicopters, they're constantly fighting against weight. Every kilogram of weight requires fuel to move, reduces maneuverability, and limits performance. But they also need materials that are incredibly strong and can withstand stress, vibration, and temperature extremes. Beryllium alloys, particularly beryllium aluminum and beryllium copper alloys, offer exceptional strength to weight ratios. They're used in landing gear components, in structural elements, and in engine parts, where both strength and lightweight are critical. In helicopters, beryllium copper is used in non-sparking tools and components because it won't create sparks that could ignite fuel vapors, adding an extra layer of safety in these complex machines. The aerospace applications extend to something even more ambitious: missions to Mars and beyond. When NASA and other space agencies plan missions to distant planets, every decision about materials is critical. The spacecraft needs to survive launch, the journey through space, entry into a planetary atmosphere if applicable, and then function reliably for years or even decades in hostile environments. Beryllium components help make this possible. Their thermal stability means they won't warp as the spacecraft experiences wild temperature swings. Their lightweight means more scientific instruments can be carried for the same fuel cost. Their strength means they can withstand the vibrations of launch and the stresses of landing. The Mars rovers that have explored the Red Planet, the probes that have visited distant moons and asteroids, many of them carry beryllium components that enable their missions. Now I want to shift gears and talk about something that connects to cutting-edge physics and future technology: beryllium in quantum computing and advanced electronics. As we push the boundaries of computing, trying to build quantum computers that could solve problems impossible for conventional machines, material science becomes crucial. Researchers are exploring beryllium ions, individual beryllium atoms stripped of electrons, as potential qubits, the quantum bits that are the building blocks of quantum computers. Beryllium ions can be trapped using electromagnetic fields, and their quantum states can be manipulated with lasers to perform computations. The reason beryllium is attractive for this application is that its atomic structure is relatively simple, making it easier to control precisely, yet complex enough to store and process quantum information. We're still in the early days of quantum computing, but beryllium might be one of the elements that helps unlock this revolutionary technology. In the world of materials science, beryllium oxide, a compound formed when beryllium combines with oxygen, has its own set of remarkable properties. Beryllium oxide is an excellent electrical insulator, meaning electricity doesn't flow through it easily, but it's also an outstanding thermal conductor, meaning heat flows through it very efficiently. This unusual combination makes it valuable in electronics where you need to insulate components electrically while simultaneously removing heat. High-power electronic devices, especially in military and aerospace applications, sometimes use beryllium oxide ceramics as substrates or heat sinks. However, the toxicity of beryllium means that beryllium oxide is used much less commonly today than in the past, with engineers preferring safer alternatives when possible. But in applications where performance is absolutely critical and alternatives don't meet specifications, beryllium oxide remains in use under carefully controlled conditions. Let me share something that brings this story full circle back to where we started, with gemstones. Remember how beryllium was discovered in beryl and emeralds? Well, emeralds themselves are a variety of beryl where small amounts of chromium or vanadium give the gemstone its gorgeous green color. But beryl comes in other varieties too. Aquamarine, that beautiful blue-green gemstone, is also beryl. When beryl contains manganese, it turns pink and becomes a gemstone called morganite. So, the same element that helps power spacecraft and enables quantum computing research also creates some of nature's most prized gemstones. There's something poetic about that, don't you think? Nature took beryllium and created both objects of beauty that humans have cherished for millennia, and the raw material for technologies that are pushing our species toward the stars. I want you to think about something profound for a moment. Beryllium is relatively rare. It makes up only about 2 to 6 parts per million of the Earth's crust, and it's not evenly distributed. Most beryllium production comes from just a few countries, with the United States, China, and Mozambique being major sources. The primary ore is a mineral called bertrandite in the United States, while elsewhere it's extracted from beryl itself. This rarity and concentrated production raises questions about sustainability and supply chains. As our technology becomes more dependent on specialized materials like beryllium, we need to think carefully about resource management, recycling, and developing alternatives when possible. Some scientists are working on methods to recover beryllium from old electronics and industrial waste, turning trash into treasure and reducing our dependence on mining new ore. It's a reminder that even as we celebrate the amazing applications of elements like beryllium, we need to use them wisely and sustainably. Here's something that might surprise you about how beryllium is produced. It's not a simple process at all. The ore is first crushed and treated with sulfuric acid to extract beryllium sulfate. Then, through a series of chemical reactions, beryllium fluoride is produced. Finally, beryllium fluoride is reduced, often using magnesium metal, in a high-temperature reaction to yield pure beryllium metal. The process is complex, energy-intensive, and requires careful handling due to beryllium's toxicity. This is part of why beryllium is expensive compared to common metals like aluminum or steel. But for applications where its unique properties are essential, the cost is justified. It's a perfect example of how advanced technologies often depend on materials that are difficult and expensive to produce, yet irreplaceable for their intended purpose. Let me tell you about one more fascinating application that really showcases beryllium's versatility. In oil and gas exploration, tools that are lowered deep into wells to measure properties of rock formations and locate oil deposits need to be non-magnetic, so they don't interfere with magnetic sensors. They also need to be strong, resistant to corrosion from harsh chemicals and saltwater, and able to function in high-pressure, high-temperature environments. Beryllium copper alloys are used in these downhole tools, allowing energy companies to find and extract resources more efficiently.